What's up, coders? Today we'll be looking to solve one of the top 100 most popular questions on LeetCode, climbing stairs. So let's get straight into it. You are climbing a staircase and it takes n steps to reach to the top. Each time you can climb either 1 or 2 steps. In how many distinct ways can you climb to the top? Given n will be a positive integer. So the note there is actually pretty nice, which will help us not need to take care of any weird edge cases. So you can also give us 2 examples here. In how many distinct ways can you climb to the second step? There are 2 ways to climb to the top. First one being 1 step plus 1 step, and the second one being 2 steps. The second example is how many distinct ways can you climb to the third step? There are 3 ways to climb to the third step: 1 step plus 1 step plus 1 step, or 1 step plus 2 steps, or 2 steps plus 1 step. Now, in order to solve this question, we can use bottom-up thinking, which is where we solve smaller subproblems and then use those solutions to help us solve the bigger problem. In order to do so, we need to consider the most basic cases, which I have copy-pasted here so we can save some time. And with these base cases, we can try and see what's happening and hopefully form a basic plan or pseudocode before we actually start to attempt the question. So, for example, the most basic case we need to consider is how to get to 0 steps, which is only one way where you don't do anything. The next case is 1 step, where there's only one distinct way and you only take 1 step. The next 2 are given to us, and the 4th step is as follows. So when we think about this question, we need to find how many distinct ways we need to get to the nth step, and hence we need to take into consideration how do we actually get to the nth step. And that is done by taking 1 step from the n-1th step, or by taking 2 steps from the n-2nd step. And so actually, in the end, the number of distinct ways that you can climb to the nth step is the number of ways you can climb to the n-1th step, plus the number of ways to climb to the n-2nd step. In order to make this a little bit more clearer, we can look at the solution for the 4th step. The 4th step solution is essentially just the number of ways to climb to the 2nd step, so these 2, plus an extra 2 steps. So you take 2 steps from the 2nd step, n-2nd step. In this case, and then for the last 3, it is the number of ways you can climb to the n-1th step, plus the final step. So looking from this, we now have a basic plan we can use to finally solve this question, which is we need to solve for the nth step. We also need the n-2nd step and the n-1th step. So we need to be able to record this information, and to do so, we can use a dictionary. So we'll call it steps equals to dictionary to initialize it. And inside this dictionary, the key will be n, and its value will be the number of distinct ways to get to n. So we only need 2 best base cases for this solution, because remember we need n-2 and n-1 to solve for n. So first, step 0, it's equal to 1. There's 1 distinct way to get to the 0th step. There's also 1 distinct way to get to the first step. And then now we can use a for loop. For example, for s in range 2, because we've already solved 0 and 1, to n plus 1, we will loop through and solve for every s. So for steps, s is equal to steps s minus 1 plus steps s minus 2. So this is essentially saying the number of distinct ways to get to s is the number of distinct ways to get to s minus 1 plus the number of distinct ways to get to s minus 2. And finally, once we've calculated all the values, we will return steps s n, number of ways to get to the number of distinct ways to get to n. So if line 9 looks any familiar, or if this solution in general looks any familiar, this is actually the Fibonacci sequence, where it goes 1, 1, 2, 3, and 5. So our final step is to hope that this works. We've run the code. Let's test it out. Oh, there's one mistake. Fix that up. Alright, sweet. No more errors. Yep. And that's how to solve climbing stairs question. Thanks for listening, and I hope to see you guys next time.